In this video, we're going to work on the ALEKS problem called naming and drawing unsubstituted esters. There are two versions of this problem. This is one version where you have the structure of some esters and you have to come up with the name. I'm also going to show you an example of the other version where the problem provides you with the name of an ester and you have to draw its structure. We're going to start with the molecule in the middle. I think this one is the easiest one to name. Esters are a little bit tricky to name. In order to name an ester correctly, you have to divide the molecule in half, and there's only one right way to divide it in half. So divided in half, we're going to start by finding the ester group. There's the ester group right there. When we divide the molecule in half, we're going to divide it in half at the ester group, meaning that we're either going to split the molecule in half right here on the left side as I've drawn it, or we're going to split the molecule in half right here on the right side as it has been drawn. Always, we are going to split the molecule at the point of the carbon-oxygen single bond. So that means for this particular molecule, we're dividing it in half here at the point of the carbon-oxygen single bond. We are not splitting the molecule apart here adjacent to the carbon-oxygen double bond. So this is going to be the two halves of this particular molecule. And we'll practice that 2 more times. Just in case that's super confusing. To name the molecule, we're going to name the part that doesn't have any oxygen atoms first. That's this part right here. And this gets named just like a regular substituent. That's a 2-carbon, we're going to think of it like a 2-carbon branch. So that is ethyl, just like a 2-carbon substituent. Then, with a space, we're going to name the other half of this ester. The other half of the ester is based on the number of carbon atoms in that particular chain. And so we're not including these 2 carbon atoms anymore. We're just focusing on this. 1, 2, 3, 4, 5. That's a 5-carbon chain. 5-carbon chain would be, normally would be a pentane. We're going to drop that last E, and we're going to replace it with pentanoate. It's a very awkward sounding name. Pentanoate. 2 words, so there's a space here. Ethyl, to name this half of the molecule, this portion of the molecule. It's not exactly half. And then pentanoate means a 5-carbon, pentan for 5-carbon. O8 is the name we give to that ester group. This is really tricky. Notice there's no numbers in here anywhere. Let's practice again. Let's practice, let's do the one up above it. Okay, so step 1, we have to divide the molecule in half. And to help us do that, we're going to find the ester group. We need to divide the ester group. It's either going to get divided here or here. We do not want to divide at the side of the carbon-oxygen double bond. We want to divide at the side of the carbon-oxygen single bond. So that means this is one portion of the molecule, and this is the other portion of the molecule. We name the non-oxygen part first, just like it was a branch, so that is ethyl. And then we name the ester portion of the molecule based on how many carbon atoms there are. 1, 2, 3, 4, 5, 6. 6 carbon atoms would be hexane. This is not a hexane molecule, so we're going to drop that E, and we replace it with O8, hexanoate. Sounds really awkward. Okay, one more like this. Find that ester group. Divide the molecule into 2 pieces, not at the carbon-oxygen double bond. Divide it at the carbon-oxygen single bond. Name the non-oxygen portion of the molecule first. That's a 3-carbon branch, so that's a propyl. Don't forget to put a space. And then name the rest of the molecule based on how many carbon atoms are in that molecule. That's a 6-carbon chain, so that is a hexane. Drop that last E, hexanoate. Okay, so what if you had the other type of problem where they gave you the molecule's name and they asked you to come up with the structure of the ester? Oh my gosh, what are we going to do? Okay, we're going to start with the ending of the name first. Pentan tells me that there are 5 carbon atoms, 1, 2, 3, 4, 5. Pentanoate tells me specifically that one of those carbon atoms, I could pick either one at the end, is the ester functional group, like that. And the ethyl in the name tells me what's hanging off of that single bond oxygen, an ethyl group. And all I have to do to make ALEKS happy is to go back through this molecule and add the correct number of hydrogen atoms to each one of the carbons.